Up until early 2026, deploying top-tier AI models meant babysitting them. You couldn't just give an AI a complex enterprise task and walk away. You had to constantly guide it, write intricate prompts to double-check its work, and watch it burn through computing budgets in the process. This handholding was incredibly expensive. To get reliable reasoning, companies relied on models like Claude Fable 5. It became the industry standard, but it cost $10 per million input tokens and $50 per million output tokens. Then Anthropic released Claude Opus 5. Their strategy was basically a massive pitwall undercut. They took their brand new flagship model and slashed the price straight down the middle. It costs $5 to put data in and $25 to get data out. You'd expect a half-price model to sacrifice some capability, but on elite coding evaluations like Cursor Bench and Frontier Bench, Opus 5 matches or beats Fable 5 entirely. You get the same or better performance for exactly half the money. It also brings distinct advantages for enterprise security. Opus 5 features a strict zero data retention policy, meaning corporate data isn't stored or used for training after processing. Plus, its internal knowledge base is updated all the way to May 2026. Delivering state-of-the-art coding capabilities at a 50% discount breaks the established economic curve for tech companies. Every enterprise building AI applications now has to rethink how much they are willing to pay for reasoning. That reasoning is also structured differently under the hood. Past models required developers to guess how much computing power a task needed and set manual token budgets. Opus 5 uses a system called adaptive thinking by default. You control this using effort levels. Set a dial to low, medium, high, X-high, or max, scaling processing time and tokens. Use low for fast data formatting, but turn to X-high for complex software engineering, giving the AI time to think deeply before acting. During these high-effort tasks, Opus 5 can split itself apart. It autonomously spawns smaller background subagents, delegating pieces of a large project, like a massive multi-file code refactor, to these secondary processes without waiting for human approval. The human user is no longer writing explicit step-by-step instructions. You act as a macro orchestrator, assigning the goal and managing the budget, while the machine figures out the actual workflow. As it works, Opus 5 runs a continuous self-verification loop. It writes code, notices its own bugs, opens virtual browsers to test layouts, and applies fixes. All of this happens before it ever shows you the final result. Because it already does this natively, writing prompts that explicitly tell Opus 5 to double-check its work is a mistake. It triggers an over-verification cycle, wasting your token budget on redundant checks. This autonomous feedback loop directly improves its ability to generate visual media. By checking its own math and code in real time, Opus 5 can produce detailed, interactive 3D elements, like rendering airflow in an aerodynamic wind tunnel, or building fully manipulable biological cells. That capacity for verifiable reasoning makes it an exceptionally powerful tool for scientific research, positioning it as the strongest available model for the life sciences. This chart shows sequence-to-function modeling, testing how well AI models design black box RNA sequences. Look at the plot in the upper right. Opus 5 achieves a higher median design score than Mythos 5 and Opus 4.8, maintaining tighter, more consistent results across every run. We are moving past the era of the predictive text generator. Opus 5 operates as a fully autonomous engine, capable of producing verifiable, complex solutions entirely on its own. When you zoom out from individual developer workflows to the macro scale of the tech industry, the implications become incredibly stark. Anthropic recently published internal engineering data that reveals what happens when a company adopts these autonomous tools at scale. From 2021 to 2025, coding output remained flat. Today, Anthropic's engineers ship 8 times as much code. Some lead engineers report they've stopped writing code entirely. By delegating to agents, they haven't typed a single line in 5 months. This massive speed-up in coding volume shortens the distance to recursive self-improvement. This is the theoretical inflection point, where an AI system is capable of autonomously conducting the research and writing the code necessary to train its own successor. Opus 5 accelerates the engineering cycle. It's not designing architectures yet. But managing development autonomously means technical barriers are falling. Developers now have a clear mandate to adapt to these autonomous workflows because the development of AI is no longer a human-only process.